Oh yeah, here we go into polar equations. We're going to start out with a lesson where we're just going to review how to graph points. That's it. Graphing points and converting from rectangular to polar form in this lesson. It's going to be great. Let's do it. So first we're going to start out with a brief synopsis of the basics. And it says of it the basics, which is weird. So just of the basics. Now I'm going to teach this as if you've never learned polar coordinates before. Like you didn't take it in pre-calculus and maybe you haven't had it before. So r comma theta is known as a polar coordinate. Basically r, that's this thing right here, is the distance, the directed distance from what we call the pole, also known as the origin. Theta is the angle measured from the x-axis, also known as the polar axis, out to what's known as the radial arm. The positive direction, just like on the unit circle, we move in the counterclockwise direction. This would be theta right here. So theta tells us where to point the radial arm, which has a distance of r. So essentially imagine that you're plotting points now instead of moving to the right and up or left and down by rotating and extending out in a certain direction. And that's what we're going to practice, is just plotting this out. Okay, so we start out with this awesome looking graph right here. That is a polar coordinate graph, but technically it's still in the coordinate plane. You get the y-axis and the x-axis. We just now arrive at points by rotating and extending out. So this says plot the following points given in polar coordinate form. So first, this is 3 comma pi over 4. So that's r and theta. You can do this in one of two ways. You can rotate to pi over 4 and then extend out a distance of 3. And that's it. That would be your point right there. Or you can extend out a distance of 3 and then rotate positive counterclockwise direction and then put a dot there. That's it. This is r and that's theta. So I'm going to rotate down to 7 pi over 6. That's all the way out here. And then extend out a distance of positive 1. So if it's positive, that's in the direction of the angle we're going in. There we have it. This would be r comma theta right here again. So this would be a distance of 2 in the negative pi over 2 direction. So out 2 and then rotate negative pi over 2 would be going clockwise. Pi over 2. There we have it. And then last but not least, it's not that bad, right? Last but not least, we have negative 1, 2 pi over 3. What do we do with that negative 1? Well, let's just go 1 in the 2 pi over 3 direction. So that would be out 1, rotate 2 pi over 3. But you want the opposite of 1. So the direction then would be the opposite of 2 pi over 3. Not negative 2 pi over 3, but the opposite direction. So we'd normally go out 1 and rotate to 2 pi over 3. The opposite direction would be down here. So whenever I have a negative r value, think of it as like every theta value is a separate number line. The positive direction would be in the direction of that angle. If you have a negative r value, we're going in the opposite direction of the intended angle. So the intended angle here is 2 pi over 3. Whoosh, we're going the opposite direction of it. That's it. All right, so that's plotting points 101. So we're going to now see one of the benefits as we round out this video of the fact that we can have multiple representations of the same point. What does that mean? Well, thanks to the cyclical nature of polar coordinates, a point can be represented in infinitely many ways, unlike rectangular coordinates. So like if you had the point 1 comma 2, there's only one way to get there in rectangular coordinates. To the right x equals 1, to upwards in the y direction, y equals 2. However here, while this is one point in space, there's multiple ways that we can get there with multiple different ways to rotate and number of times that we rotate. So let's start out with just 1 negative pi over 3. And I'm just giving you a rough graph, no longer like a nice formal polar graph like we had in the last slide. So 1 negative pi over 3 would be out 1. Let's say that this is a distance of 1 right here. So we're out 1. Negative pi over 3 would be in the counterclockwise directions positive. So this would be clockwise. Pi over 3 would be roughly down here. So roughly out there. That's it. So that would be our point. Distance of 1, if you will. And then there's your point. So let me erase all those extra little dotted lines, get rid of those johns. Now, the point is that we can get to that point in a multitude of ways. What could we do? Well, you could extend out 1 and then add 2 pi to that. That would add a single rotation, right? And so that would give you the point 1 comma 5 pi over 3. And that's the same exact rotation. So that's over there. Sorry, the same exact location. So that's out 1, rotate this way instead of out 1, rotate that way. So we got to the same place, but with a different rotation. You could also do, ooh, this is fancy. We could do negative 1, and then the point opposite that would be 2 pi over 3. Why is that? How does that work? Well, -1, let's get to the 2 pi over 3 first. 2 pi over 3 is here. And then we go -1, so that would be the opposite direction of the positive 2 pi over 3 would be this way. And we get there. A multitude of ways we could get there. Let's do 1, and now we'll subtract 2 pi over 3, -7 pi over 3. Why not? So what's that going to equal to? Well, 1, -7 pi over 3. How did I get there? By the way, I subtracted 2 pi this time from here. So it's like I go to the point, and then I go around another 2 pi in the clockwise direction. So there's infinitely many answers. I'd say adding 2 pi and subtracting 2 pi are two easy ways to get equivalent locations, but different ways of rotating. And then doing the negative is also another nice way. That's it. All right, so that's plotting polar points 101. Very simple. It's a rotate and extend out. That's it. Different ways of still plotting on the xy coordinate plane, but that gives some really cool curves when you add in rotation rather than rectangular movements. I'll see you in the next video. Peace.